Okay, welcome everybody to October's meeting of the Mornington Peninsula Astronomical Society, and people will continue rolling in as the evening goes on. There's quite a few out there. There's a picture of a plover. For those of you who were here last month, we had a plover and 4 eggs down on the lower slab, which dutifully disappeared in the subsequent 3 days after the meeting. And by the time the Saturday members' barbecue came along, the eggs had completely gone and the birds had completely gone as well. So I suspect that they were probably taken by a predator of some sort, maybe a fox. Okay, so tonight, first of all, welcome any new members here. Is there anyone here who's joined for the last couple of months? Yeah, put your hand up. Yeah, one or so. Yeah. Welcome to the Society. Our new members officer, if you haven't already met her, is Nerida. She's out in the back room, and we'll point you in her direction when we break for tea break afterwards. Now I'll take about the first 5 minutes or so going through what the Society's been doing over the past month and what's coming up in the next month. Then I'll hand over to our guest speaker tonight, Max Burrows, to talk about night birds on the peninsula. Then we'll break for tea break for about 10-15 minutes, and those of you who are waiting on the 2020 Night Sky Almanacs, they have arrived, and Simon has those for sale at the back there. Members of course get a discount. Then we'll do Sky for the Month. That's been put together by Mark Stevens, but Mark is enjoying storm chasing in Japan at the moment, and he could have picked a better country to go to given the typhoon that's hitting there at the moment, but that's why he's not here tonight, but he put together the slides, and we'll have someone presenting that for the time. Then I'll throw over to Ian Sullivan to maybe give us a couple of trivia questions if he's got those prepared. Yes, I think so. Yeah. You'll do it spontaneously. Yeah. Then, if we have time at the end, I'll show you some 3 fairly short videos. Go for about 8 minutes or so each. One is of the person from the Apollo 11 landing. You remember the 1201 and 1202 alarms, the one who actually made the call on that, and also the one who wrote the code behind it. We've got a short video there by Amy Teitel, who visited the observatory here a couple of years ago. Then I'll show one that Mark Hillen brought to light about a month or so ago, of a damaged mirror in the USA, and that's by a young Australian physicist, Toby Hendy. Unusual name for a female Toby, but there we go. And then if we end up with time at the end, you'll all be familiar with how helium sounds if you try speaking with a mouthful of helium, a lungful of helium. This is showing you what happens if you try it with all the other noble gases as well, and which is quite interesting. Okay, now it's been a very, very quiet month for the Society, in fact unusually quiet. We had the members' barbecue and maintenance tasks done here at the observatory a few days after the previous monthly meeting of the members here. A couple of days later we had a committee which was held here at the observatory. And although we didn't actually put on a special an event for the Murchison meteorite anniversary, because it was the 50th anniversary since the Murchison meteorite fell, and those of you who were here at the last meeting would have heard all about that. The town of Murchison in central Victoria put on quite a big show, and did anyone here actually go up to Murchison during it?
I forgot it.
Oh, yeah, a few people forgot it. The video that I showed last month from the Field Museum that actually own about a quarter to a third of the Murchison meteorite in the USA, the person speaking on that was actually at Murchison giving a lecture at the time, and there were lots of scientists came from around the world to talk to the public there actually over that weekend, so it was quite busy. On the 4th of October was the only outreach that we did in the last month, and I was told by different people, numbers ranging from 48 up to 70, so I put the 70 in there. It was 100% clouded out that night, and the observatory was actually booked out, so that means about 30 odd didn't show up on the night, even though they booked and paid. Since we last met, the Society is on Instagram for the younger members who actually know what Instagram is. And our new members officer, Nerida, who will put up her hand, so the new arrivals here can see who she is, the one carrying the coffee mug at the back there. And we didn't do any school or scout guide nights during the month, which is quite a contrast to the month before, where we were just about a saturation point, doing it a couple of times every week. Now, things are quite different from the month looking ahead. Between now and next meeting, we've got a few things on. Starting tomorrow night, we've got a viewing night out at Safety Beach at a camp there, and we do need a couple more telescopes to turn up for that. I think we've got 2 at the moment, and I'm talking. Right. So not too far from here, given that it's Safety Beach near actually near the beach. Then this weekend is the barbecue on the Saturday evening or Saturday afternoon, starting at 4 o'clock. When again we'll start with maintenance activities that have to be done around the site. And did you want to mention anything, Anders, specifically?
Nothing specific, just a free ride on the mower for those who missed out last month. I know Mark wanted, but
So from that we'll be running a training course on the ride-on mower rather than one on the observatory instruments for those who haven't been on the ride-on mower. Then after a committee meeting next week, 1 week from tonight, I'll be going up to the school in Kensington who won our national competition to win a moon rock. Because, as I showed last meeting, the winner of that turned out to be a 7-year-old girl from Kensington, up at the primary school in Kensington. And actually, it was a very prolific school because the top 10% of answers, actually 3/4 of them came from that school, and all spread around. So they did more than just try to Google search. They actually thought about how to arrive at the answer. Then on the 31st of October, later that week, we got Bayside Christian College. It's been a few years since we've been there. They've changed quite a lot since, and that one is going to be their Year 10s, starting at 8 o'clock, and we do need people to come forward with telescopes on that one. 1st of November, the public night here at the Briars is already fully booked out. We've got 115 people booked, and there's probably going to be a few others coming. Just dropping in on the off chance, so we'll have all the chairs out that evening, so that will be at the first Friday evening. So the next ones that are available for the public to book are now the month afterwards in December. Then a week later we've got the next Scout Clubs and Guides night here at the Briars, and we don't currently have any bookings yet, and if none come forward we'll cancel that evening at about 1 or 2 days out. So that may or may not necessarily go ahead. 13th of November, we've got Durinya Primary, who are staying at the camp next door here. While we have visited Durinya Primary actually at the primary school in Frankston, they've got their I think it was year 6, year 6 extension students, which is their brightest of the bright coming along, and so consequently we can probably expect some pretty curly questions delivered from them. So that will be here at the Briars, not actually at the school. Then I believe Dave, Jamie and a few others, a couple of others have got the Radio Fest on, is it at the Sunday or the Saturday? Sunday? Down at Rosebud at Eastbourne Primary. No other members and actually needed to go along to that because it's not as if we're going to be doing a nighttime activity or a talk for them. But more a presence there and show them a few things about the society. Solar scopes, yeah. With the so this is the ham radio group effectively. So it's like a point of collaboration with something outside of traditional astronomy. Then during November, of course, November's famous for the Leonids meteor shower because that's a shower that comes from the constellation Leo, as you'll read in Nerida's article when it comes out in the Mornington Peninsula news in the not too distant future. That will actually peak on the night of the 17th, morning of the 18th. So if you really wanted to see the Leonids this year, there's going to be interference from the moon. So it's a gibbous moon, which means it's not too far off being a full moon. But your best chance of seeing it is between midnight and dawn the next morning. So it's not necessarily a convenient hour for most people, but it usually puts on a fairly good show, and occasionally it puts on one monster show where you get hundreds of meteors, but they're pretty rare.
So is that run for most of November, does it? But that's when it peaks?
It does, yes. So the number of meteors that you will see sort of starts kicking in about the 6th of November, reaches a peak at about the 17th, 18th, and then it drops off to the 30th. So you'll see them at other times during that period of time during November, but your best chance of seeing them is the maximum. And of course, these meteor showers arise from where a comet has gone through the solar system in the past and left debris behind from its tail, and the Earth is actually sweeping its way through that debris that's left at that part of the solar system. So every year when the Earth goes around the Sun, it will sweep its way through that debris trail, picking up a few more, and you see a meteor shower at that time every year until the debris is completely depleted. And our next meeting here is on the 20th of November. Now, one for the very, very distant calendar is in May next year on the 16th. We've now got a geological expedition planned to Point Leo for members on a Saturday during the daytime. So this is a daytime activity looking for fossils and volcanoes and geological features on the peninsula, so that should be quite interesting. Now, having said that, I will now hand over to Max, who's President of Birdlife Mornington Peninsula, and thank you very much for coming up. They actually do meet here at the Briars, or at least they have their committee meetings here at the Briars every few months. And so he's certainly no stranger to the Briars, and this is a picture that was in Peninsula Essence, one of the glossy magazines that indeed Nerida sends things about society to as well.
That was on a good day.
That was on a good day. And as you see, he has binoculars, the same as we do. I'll just flip over to Max's slides, and I'll hand over to Max.
Thank you. Thank you. Thank you for inviting us, by the way. Thank you. Yes, well, I'm the convener of the Birdlife Mornington Peninsula Group, Birdlife Australia. Birdlife Australia was formed a few years ago. The combination of the two main birding groups in Australia to form Birdlife Australia and become the peak advocacy group for birds in Australia. So we've got over 100,000 supporters and quite a number of members as well. On the peninsula we've got about 300 members, and BirdLife Australia is a conservation education organisation, and they've got a few projects on the go at the moment. The big one that's just happened that they've been involved with is you've probably heard of the waders that come down from Russia and Siberia every year and Alaska to Australia and disperse across the Australian continent. They were being badly affected by the Chinese Yellow River situation, where the Chinese were actually reclaiming a lot of the mudflats there for industrial purposes. And this is where the birds come down from Siberia and they feed there before they make the long flight to Australia, and the reverse happens. But anyway, the governments over there now have decided to reserve a large part of that those mudflats, so that's good news for the birds. We also are looking at Carnaby black cockatoo in Western Australia, Regent honeyeater in Victoria, and we're very active in that sort of field. On the peninsula, we have 2 outings a month on where we go to reserves across the peninsula, bird watching and recording the species, and we keep a database which is also extended into the national database. It's sometimes we go outside the area. We go to the Western Treatment Plant, preventative new games, but mainly we work in this area. The area covers the top of Frankston and Piersdale down the rest of the peninsula in terms of point of view. We produce a quarterly magazine, and I'll leave a few of these newsletters you can have a look at. We've also produced a book, Where to Find Birds around Frankston and the Mornington Peninsula, and this gives you a look at all the reserves and how to get to them and what you might see in those reserves. The back of the book is also a list of the birds that are found on the peninsula. I'll also leave a few of these information about us, what we do, and if anyone would like to join, you're most welcome. Okay, I thought as you people sort of work at night, you might like to have a look at some of the birds that hang around, and we've only got probably 5 or 6 night birds on the peninsula, and they're very hard to find. We don't get too many reports on any of them, apart from one, which is the tawny frogmouth, and we'll talk about that as we go through. Now I'm going to operate this. That was nice. What was that? Help! This is not my computer, by the way.
That's all right. Just go that
Oh, that one.
That one.
Yeah. Birds of the night on the peninsula. Okay. The first thing we're going to look at is the tawny frogmouth, and there they are. They're very cryptic, and they rest in trees like that during the day. We were doing a community meeting today down at the Briars Visitor Centre, and we were told that there's a nest just along the walkway in the reserve. There's a tawny frogmouth sitting on eggs. The nest, you can hardly call it a nest really, it's just sort of in the fork of a tree, just a few sticks put together, and quite often the babies fall out and they're killed. Tawny frogmouths aren't owls, by the way. Most people consider they are owls. They're not related to owls, they're related to nightjars. So that's a misconception held by a lot of the public. As against owls, they've got very weak feet. Owls have strong talons, but they have very strong beaks. So if you're ever handling a tawny frogmouth, don't worry about the feet, look for the bill. So there's a little family party, and you can see they're very cryptic. You can walk right past them and not see them, and they adopt a stiffening posture when they're disturbed, to form part of a tree, like part of the tree. So, yeah. They have a little call that goes boop, 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 boop. I think we discussed that just a little while ago, hadn't we? The call, repetition. Yeah, they're a fascinating bird. All night birds, owls and frogmouths, have specially adapted feathers that they don't actually make a noise when they fly. So when they fly, they're very silent, you won't hear them. These birds feed on insects, moths in the trees. They might take mice, but they don't take any possums or any of the big animals. They do also, strange enough, roost on the ground at some stages. I had a property out at Langwarrin. I did come across a couple just resting on the ground, which is a bit dangerous. They often get knocked over on the roads too, because one of the insects are attracted by the lights, and unfortunately the cars knocked them over. Okay, now we're into owls, and there's 2 species of owls, 2 families of owls on the peninsula. There's the Equinox and Teitel. This is the Equinox doesn't have any facial discs, the other one does. So these ones don't focus on with their hearing on with the disc that points into their prey, but they hunt at the night time, and they take up to brush-tailed possums, ring-tailed possums, echidnas, all those animals, and they have a peculiar habit of when they catch a possum, they'll eat half of it, and then they'll sit on the branch with the other half in its talons the rest of the day. So you'll see them roosting it during the daytime in a tree with half a possum hanging off their talons. They nest in deep hollows, so they need very old trees. And they roost during the day. Sometimes they roost out in the open, like this pair was. But they're the biggest of the owls. They're huge. They're very big. They're the top predator in the owl.
That picture doesn't. I've seen a powerful owl.
Yeah.
It was drawn to my attention up there in Smith Gully.
Yep.
In that place. You saw the poo on some things down on the ground. This is the bloke that was taking us around. So there we are. Look, right, out come the binoculars, and we look up. But the animal, look, it's about up to your waist, wouldn't it? If it stood on the
You
floor.
don't need binoculars, we just underneath one.
If it stood on the floor, it'd be its head, the top of its head would be up to your waist, wouldn't it? It's a big,
They're very big. Yeah,
very
right.
big. That picture doesn't quite. Yes, but they need a matchbox next to it or something. No, you can't do much about that. But would those be fully grown?
Yeah, look, they could be sub-adults.
Yeah.
They could be sub-adults.
Yeah, just the size of the.
Yeah,
You wouldn't argue with one of them. No,
they're a huge bird.
Yes, they're heavy birds, and they.
Don't mess with them.
And they're certainly well protected, aren't they?
Yeah.
Yeah.
Yeah, they've got huge talons. Yeah. And
Would
they
they
need
take cats and dogs?
Sorry?
Would they predate on cats and dogs?
Yeah, well, they could do. I haven't heard of that, but they do.
Yeah, I mean, a
Small cat.
maybe, a small cat. We've got to watch out.
I mean,
Sure.
rimtail possums are fairly big possums, you know, so dispatch them pretty quickly. They do roost sometimes in along creek bed gullies, you know.
So how would they kill the possum? With their talons or
They go
action
with
or
the talons and they rip it with their
what? Okay.
beak, yeah. This is their smaller cousins. This is called the southern boorbooks, and they again feed on moths and small animals, mice, etc. And they quite often roost. There's this one seen in sheds. There was down at Coolart. There was one that used to roost in the old stables down there in the rafters. Just recently they've been separated from their Tasmanian cousins. The Tasmanian cousins now called the Norfolk. And as against these been called blue rooks, and Norfolk has actually been found on the southern coast of Victoria as well. So there's now two different species of that particular bird.
In what way do they differ?
You've got me there. I haven't gone into that yet. It's only just happened, so they're probably either darker or bigger. So this is the barn owl, and this is the most, well, it's found all over the world. It's found in every continent on Earth except for Antarctica, and it's found right across Australia. And it can issue a pretty violent scream. In the old days, some of these the pioneers used to think someone was being murdered by the screams of these giving up. They feed on rodents, rats, mice, and they're very susceptible now to being poisoned by rat poison. Yeah, so and just recently we've had a real lot of them being found dead on the peninsula. Yeah, so whether it's been through rat poison or whether it's just a scarcity of food. They also nest in.
How would that happen, Max? How would it happen? I know there's been controversy about other things with the poison, just like how was it done through mismanagement or?
No, I just think that people poison rats and that's what happens.
Okay.
Yeah. It's a, yeah. And they again, nest in, large, hollows, and they roost. Well, there's one roosting in, Dunnings at Mornington at one stage, up in the rafters down there. So, yeah.
Is it native to Australia?
Sorry?
Is it native to
Yeah,
Australia?
yeah, it's found all across Australia, yeah.
So it wasn't introduced by
No,
early
no,
European
it's
settlers?
just one of those, I mean, the Australian one would be a subspecies of the main body, yeah.
So they're not the same as the ones in the UK?
Yeah, they'd be basically the same.
Yeah.
And that's the one, this is the one, Teitel with
Mm.
the facial disc, which they can use to focus on their prey at night time in the dark.
Would they scare the prey balloon with that face? Catch a bit of moonlight on that face and,
Well, it's rather cute.
yeah.
And this is a funny little fella. This one's called an nightjar. And one was just recently seen, and this is a picture of it, I believe, down at the Briars here. So it's a bird that is a night bird. It's not. It's that's what it does. It sits in the hollow, in the face of the hollow, and in the sunshine. It nests and roosts in the hollow itself. It's again feeds on insects on the wing and also on the ground. There he is again. Quite happy to be just observed there, but at one stage, books I've read that said that it was extinct on the peninsula, but now it just appears every so often. It's like I guess a vagrant that comes in. Every so often you get a report of one. They're not easily seen. Most night birds aren't easily seen, are they? That's what it looks like when he's out of his hollow. Got a fairly full tail. Okay, so you look at these ones, and these are what you're talking about. Well, they actually aren't plovers. They're actually masked lapwings. And I just put these in because quite often they fly around at night and they squawk at night as well. So some of the birds you're hearing at night time are probably these. They do move around at night time and they call. So with them nesting on the ground, that's always at risk of foxes and whatever. But they also are known to roost on roofs, nest on roofs. And also they've got a big habit of nesting in roundabouts. So we'll often get a call, please come and help, rescue this bird off the roundabout. Yeah, right. I don't think so. They actually have a spur in their wing. Yeah, and that's a hangover from.
Is that Mr. and Mrs., is it?
Yeah, that's Mr. and Mrs. That's Mr. in front and Mrs. in back, or Mrs. in front and Mr. in back. You take your pick. Make a judgment. Well, that's my presentation. The other thing I just perhaps wanted to talk about, has everyone heard the night parrot? Anyone heard the night parrot?
I've heard the name.
Heard the name? Okay. The night parrot is a small parrot, native to Australia. It's about the size of a budgerigar, a bit more plumper, and it's green with a flecky black body. And it was thought to be extinct for, well, about 100 years. It was initially found by a man, or collected by a man called Andrews in the 1800s in the Gawler Ranges, which is some ranges sort of northwest of St Vincent's Gulf in South Australia. It's a denizen of the Spinifex country, so it's a very arid country, no water. And he made quite a few collections of that. He was collecting for another ornithologist. But suddenly, when he finished, the bird wasn't seen again. And that right up until just before the turn of this century, when one was found dead on the side of the road. And I think Dick Smith at us, they offered bucks to go and find it if you could, find it. Another one was found in one of the nearby national park, which was calculated. But fortunately, a few weeks or years after that, one of the naturalists out there he actually did find it. So after being missing for 100 years, it was found. It's now at a property up there which is sort of protected by the Bush Heritage, I think it is. They've identified the call, so that helped, because this bird only comes out at night time. It's very cryptic, it's only a small bird in a vast, arid spinifex country. So they've identified the call, so they can now go at night time and listen for the call and establish that there are birds in the area. The bird apparently doesn't feed on the spinifex, it goes to nearby saltbush areas and feeds on the seeds of those and mainly gets its moisture from the seeds of the plants it eats. So, and then just recently it's also been now found in Western Australia, I think, and possibly will be found in Northern Territory. Yeah, a very cryptic bird. Yeah.
Has it ever been sighted on the Mornington Peninsula down this far?
No, it needs spinifex. The only place in Victoria it would possibly be is up in the very northwest corner in the Mallee country, up there. That's the only possibility. I mean, someone did say they sighted it some years ago up there, but never been confirmed. So there's not many confirmed reports, but it still exists, which is amazing after 100 years. Anyway, got any questions I can answer?
Max, well, I was told you earlier on, about, I've been to these meetings and checked in the green wedge, and the $64 million question is I want to see bushland, not the one I've been on about, but we never heard of any success stories. I already told you the one in the Cook Islands, but what's the actual attitude from this council towards the bushlands and protecting it and getting more birds back on the scene? What's the general attitude of the council? Because I don't like them anyway, so.
Well, yeah, we've got a fairly good relationship with the council. We get on well with the rangers and whatever. The people I deal with, the rangers, they're very dedicated to what they're doing, yeah. But otherwise, I'm not a councillor, I can't answer the question. Sorry, do you want?
Yeah, you brought in the lapwings as part-time night birds. What about magpies?
Yeah, well, a lot of birds call at night. Willie wagtails call at night and all that, yeah. I don't know they do too much flying around.
No.
I know they do call, yeah. Well, actually, at the moment, my wife wants to feed the magpies at my place, and she gets out the front of the house, and all you can see is just a sea of magpies. There's about 40 of them. They just all come in, like fighter planes. Land on the roof and on land on you, So, yeah, it's just quite a sight.
And you feed them on rump steak, didn't you?
No.
Do they have?
Fillet steak. That's why they come.
Have they got many migrant birds that come from the north and that? Have they got many night birds that come down from the north?
No, not really. They do fly at night. All the birds that come down from northern hemisphere do fly at night. They fly very, very high at night. So they fly. So a lot of them fly continuously from.
I remember years ago when, for the very first time in the UK, they spotted a snowy owl, and it hit the Hebrides, and they was all trying to get it to breed, and that. I was just thinking that think anything like that had ever come all that way from down there, like. Okay.
No, we don't. The birds we get are waders. We get shearwaters from Japan. Waders like snipe, stints, godwits, all those sort of birds come down. There's about 36 species all told, and there's quite a few vagrants caught every so often.
If you live a little bit outwards, you usually problems with rats, and you have to poison them.
Sorry, I didn't get that.
If you live a little bit outside, you end up having problems with the rats, and you have to poison them.
Yep.
You could say, well, you could have a cat, but a cat kills more birds than they kill rats.
Yeah, about 2 million a year.
Yeah, that's right. So, are there any poisons that are actually bird friendly? If you know what I mean.
Not my expertise, I'm afraid.
Okay.
I couldn't say. There probably is.
Lead poisoning.
Yeah. You've got to be able to aim.
You can get a trap that doesn't kill the rat. You can buy these little traps that don't kill the rat. So you can identify the rat and you say, well, this is an Australian native rat, so you can let it go. But if it's a European rat, you drop it into a bucket of water. And it doesn't survive that. So that's your only option.
Okay. Any other questions? Yep.
Max, one of the things that the Society's got interested in recent times is we've become a member of the International Dark Sky Association. And that association spreads the word about the effect of the sky getting darker because of light pollution, or brighter because of light pollution, on animal life. And we certainly see a lot of stated evidence that bird life is being affected, particularly night birds, being affected by the fact that they can't navigate under the brighter skies.
Right.
But I'm just wondering, what evidence is there that that really happens?
I can't tell you that, sorry.
One of the things that the committee is working on is that we want to support the Briars parklands to become a dark park designation.
Right.
And in Australia, there's only one park that actually has a dark park designation, and that's up in New South Wales.
Okay.
So we're hoping to get support for that.
Right. I don't think the owls are mine.
Yeah, the owls, you were saying they've got the big discs to focus when they're hunting. Does that mean the light you're talking about, not the sound? The big discs around there?
No, that focuses the sound.
Oh, well,
They can
okay.
hear the possums in the trees and whatever, yeah.
All right.
It focuses the sound, yeah.
Would any of these night birds, can you breed them out of nesting boxes? Max, could you? Yeah, if you put nesting boxes out in your gut, would they breed?
Yeah, they do. They put nesting boxes out for powerful owls.
Okay.
Yeah, they do, yeah.
Yeah, a powerful owl will come in the nest, yeah. But you have to be careful and keep away from it, wouldn't you?
Yeah, but you've got to have a very big nest box too. They require a deep hole. The other problem, I guess, with nesting hollows is that they require old trees. Like for a tree to become suitable as a nesting tree with a hollow is about 200 years old. You know, so if you take out an old tree and I say we're going to put in, 4 new ones to take the old one, well, 200 years later you might be okay.
Well, will any of those owls actually take other birds as well?
Yeah, at night time, yeah. Roosting birds.
And what's the rarest bird on the peninsula?
The rarest bird. We got a white-winged chill the other day. It's not seen very often down here. But that owl nightjar is probably one of the rarest as well. There's a few. Like we've lost a lot of birds on the peninsula. We've lost about 40 species since the 1800s. There used to be emus running around the peninsula.
Have they bred anywhere else, or they've just disappeared?
Oh no, they're bred up there.
They've gone to other places, like.
Yeah, like we modified the peninsula to like we used to have.
Only where I'm on a bed down in Pound Road at Warren Park, this woman said to me that used to be home to the black cockatoo a long time ago, and now it's just a crap house. I'm sure I've been cleaning it up for the last 2 years, though.
Yeah, so then. Fred, you messed me up. Yeah.
And what about the infamous orange-bellied parrot that sometimes...
Yeah, oh, well, there's not many of those left in the wild, but there's a big breeding program. In fact, when I was out Millard Sanctuary out at Piersdale, they've got a big breeding facility out there, and they breed well in captivity. The only problem is with orange-bellied parrots is they spend the summer in southwest Tasmania breeding, and they come across Bass Strait and then disperse along the coast of South Australia, Victoria, and New South Wales. Used to. So, you know, if the wild birds die out, we don't know whether the captive bred birds would be able to do that. That's a problem.
Do they ever go back? They breed down there in Tassie,
Yeah,
and then come north.
for the
And
winter,
do they
they
go back?
Yeah,
Go back for holiday, back to Tassie?
Not a holiday, they've got to bring the kids up.
Yeah.
Years ago, over at Yellingbowl Park, they had a breeding program for the helmeted honey eater. How did it get on? Did it come back?
Sorry?
The helmeted honey eater.
Helmeted? Oh, yeah, well,
Have they
yeah.
come back?
well, there's probably, with the helmeted honey, there's probably a genetic problem there.
Oh, okay.
Yeah, and there's a breeding program for them, I think, at the Hillsville Sanctuary and the Melbourne Zoo, I think. Yeah.
Nobody's tried to set up an island and use that to breed, so that get rid of all the rats on the island and people and those kinds of things and breed away.
We're talking about French Island now.
Well, we're talking about New Zealand. They've done that with the
They've done it in a couple
with
of
the
islands.
kakapo parrot in New Zealand. And
French Island, they just introduced the eastern barred bandicoot over there. So, yeah, there's no foxes over in French Island. And they've done a pretty good job of locking up the cats too, I think, over there.
And the Teitel wetlands,
Yes.
is that going all right with its waders and things?
Speaking of that, we're having a World Wetlands Day there on the 2nd of February next year.
Yeah, I'll be on to that.
So there's
I'll be on to that.
a big day down there for have a look at the swamp and the
They got the
wetland.
helmeted, they got the-
We've just been down there actually, and it's really full of water. Strange.
Mm.
Yeah, there's a lot of water there.
Is there any threat about the extension of the freeway going through the wetlands?
Yeah, that's always on the boiler, isn't it, that one? I know it's on the, proposed, but, yeah, these things happen, Jeff Kennett was gonna put a road right through the Cranbourne Gardens.
They want to put a marine precinct, boat precinct up in Bungay Road, and they ain't so happy about that because that's in the Greenwich and all.
Yeah, I'm
There'll be
actually
another
meeting,
uproar next week at the council meeting.
the member for the Nepean in a few weeks he wants to discuss those sort of problems.
Greg Hunt's proposed the overpass over Jetty Road, that would extend the freeway. And the bottleneck will be Bonnier Road, so the extension of the freeway will be well on the cards.
Well, where does it end up? It's sort of,
Truman's Road, onto Browns Road.
Just extends the problem to the next.
the next, that's right. Yeah.
And you mentioned before that you have this database of all the birds in Australia and their audio, sound, and does it also record when they're being sighted or where they're being sighted?
The database does, yes. Yes, it does.
So when your group goes out on field trips, I mean, what's the sort of thing that they typically do on a field trip?
Well, we observe the birds and record them, and
So what do you convince yourself that it's right, or you have to
No,
always have photographic
no,
evidence?
we know that it's right.
You know it's right.
You're working with Museum Vic at all?
Sorry?
Museum Victoria.
Yep.
I've got an app that my wife uses. She's doing a lot of watching. They got an app that's absolutely fantastic.
That's the bird one.
Yeah.
Yeah.
Are
There's
you
a couple.
working with that at all? Do you contribute photos or we work with them?
No, well, there's a BirdLife Australia photographic group,
Yeah.
and they've got a big library of birds, yeah. I've got the Morka map on mine.
Yeah.
phone,
I just know the Museum Victoria one is really good.
Yeah, the Morka one's good too. Yeah. Gives you all the calls and birds found and, yeah.
So do you actually go out at the night time sometimes?
No, we don't go at night time, we're frightened about that.
That's probably understandable, looking around the room.
So would you
Have the
recommend,
same problems as we
I'm out of a comfort zone tonight, by the way.
would you recommend, the average person putting breeding boxes or certain types of trees or something to help?
Well, you know, native gardens are always a good thing, because there's grevilleas and banksias, which the honey eaters like and feed on. Yeah. Nest boxes are a bit of unless they're done properly, they can just be homes for bees or introduced birds like common miners or starlings. So they make boxes these days that only rosellas can get into. And also, where do you put them? So we need
There's one thing I noticed being an ex-gardener, groundsman now, Max. These schools, a lot of these schools, the school grounds, they don't seem to be intact with they don't seem to encourage much in the way of putting native trees around, and that they don't seem to want to do much hard work. I don't know why it is, but I've been down stacks of them, and the outbuildings are just absolutely disgusting.
Well, I mean, I guess they don't have money in the public schools, but I mean, it's sort of like a moving population. Well, you might have some teachers or students who are going to put in a native garden, but they go, the next one come along, they might be interested. It's something that it's very hard to do. I mean, I was used to live at Coringal Primary School, and I planted out a native garden there, but after 12 months, it just gets neglected. No one.
See, when I worked at the Wilson Botanic Park in the 90s, we was intact, and I said when I gone on about this bushland, make contact with the Gould League, which is the children's environmental programs, but they do a lot in Melbourne, the Gould League, and that, but they don't do nothing on the peninsula. There's nothing in the peninsula at all.
Yeah, when I was a kid, that's many years ago, the Gould League was the bird association. We used to get lovely little colourful stickers, certificates, and it was lovely. But they sort of dropped out of
See, what happened?
They dropped out of the scene for a long time. They still exist, but they don't exist in the same form.
I'll tell you where they are. They moved from Richmond, and I went to see them down in Genoa Street in Moorabbin, and they're now stationed at a place called the Page Primary School, right? And I was talking to the woman. I said, "What contacts do you have with the peninsula?" She said, "We're thinking about going round there, but I don't know whether they did or not."
No, we don't have any contact with them.
Yeah.
But we reckon we do a good job anyway.
So how many members do you have on the commission?
Just under 300.
Yes, more than we have.
No, we've got
We've got more than that, don't we?
How many you got?
350, 360.
We've got 370.
But if you get a group of people around the stargazing or bird watching at night, if you get a group of people out in the dark to do anything, they'll get torches out.
Yeah.
And the torches will kill the sky for viewing the stars, but it'll also kill the viewing of the birds, won't it?
Yeah, like, I've been out bird watching at night time, and it's really difficult to find the birds for a start.
Yeah.
So it's not a productive thing for a group like us to focus on night birds, really.
It's not like rabbits. You sort of shine the light in their eyes and they freeze.
That's right.
Yeah, they don't.
I do the same thing.
Yeah.
Okay, right, all right.
All right, any other questions? Thank you, Max. With that, I think we'll break for tea break now
Very
for
good.
about 10 minutes and come back in here at 9:10. Have the next one.
I'll just wait those reserves and
It's in the back.
You don't want to hurt the best of wildlife.
Run away from it. Simon was trying it first. Simon.
Now we're going to have Sky Murphy. Out from Pluto.
Hi everybody. Thank you for being here. During last month, excellent talk by Daniel Price. He mentioned Pluto briefly. Oh, who's got the press thing? Can you advance the slide, please? And you can advance it for me? During last month's excellent talk by Daniel Price, he mentioned Pluto briefly. So it occurred to me that I'd like to share with you some thoughts, but not so much about Pluto itself. It was from the sparks of emotion when he mentioned Pluto. It's about the communication, the importance of how we communicate to the public, things like scientific information. So when Pluto was reclassified, the word got out that Pluto has been what? Demoted. Even these days, millions and billions of people in the world can still fill in the blank that Pluto has been demoted because of the sensationalization to get some people rich from that. Now, I thought that we can play some games here. It is like when you have short-sightedness. To get to the good vision again, you have to go the other way, okay, with the corrective lenses. So let's think about, just for fun, what could we say differently, even right now? let's think about how Pluto has been promoted to what? Now, we don't have a lot of time here. I like to run a workshop for a day, but I will count from 10 down, okay? And you think Pluto has been promoted to what? And then you shout out. Even if you shout, I don't know, but shout. So that we can get some brain cells working, okay? 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, go!
Who cares?
Thank you so much. That's it. That's what we want. Pluto has been promoted to, and please go to E-Scorpions. I think I'm going to start a thread and just throw in whatever ideas, okay? We need to be creative and thinking creatively. So, next slide, please. You get to tell the president of the association what to do. Okay, so here, what is my point, do you think? Pluto is just a dot over there. I used to lecture, so this used to be my kind of... Pluto is just a point over there, a dot. But what is my point here? Can you see what's in my dot point?
It's a blue dot.
There's a pale blue dot there, and we won't have time to get into this less than 1 pixel of the Earth. But let's think about this pale blue dot, that we on this less than 1 pixel move around, and then we observe the sky, and then we try to work out what's going on. Okay, so this thing rolls around. Peter is very obedient. I just look at him and just jump to him. Thank you. It's good I joined this association. So it has been observed, right? Everyone has observed personally that stars move about 4 minutes ahead each night. Now we speak at public night, school scouts and friends, etc. And people, in their innocence, they trust us. For them. So we have a responsibility not to just tell them, just remember that figure 4 minutes and don't ask any questions, because they would ask a question, which I encourage everyone to do, okay? Pity there are no children here, because I want children to revolt and ask some more. Why 4 minutes? Okay? And if we can't explain to them, well, go again. So let's have a play here. Instead of just PowerPoints, because we have been PowerPointed to nearly death. A lot of people are visuals, that's fine. A lot of people like myself, I'm not auditory. You can tell me blah, 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 and I don't understand it. A lot of people are very bright, fail out of the school system because they are neither. They are tactile and they need things to play with, move around. So I would like us to play tonight by coming out to make mistakes with me, please. I've changed the words slightly, but we need creative thinking. And we need to not just sit there getting stuck. We need to move around. That's why the music. And we need to take risks. Actually, it's quite safe tonight. I need 2 volunteers, please, at least. 1 to just sit and be shining as the sun.
Oh, me.
Sit. Thank you. And 1 more, a little bit agile, because I would like you to be the earth and move around, okay? And at most, half of the room, please come and support us and line up here. There's a point I'm trying to make. So when I count down from 10 to go, or whatever, at least 1 more come to be the earth with me. You are very crucial. And at least half of the room line up behind us, please. Oh, thank you so much. Success already. Okay. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Lift off. Thank you. Again, we don't have much time. I'm gonna rush a little bit. Now the sun is shining over here. We don't need any nuclear reactors on Earth. We've got a gigantic one up there if we know how to use it properly. And here, can I touch?
Yes.
Earth, please come and stand here. We are about, solstice. Now you lean forward a little bit just to illustrate. The Earth leans forward a little bit, okay? So Australia is kind of about the backside, so we are in winter. We get a lot of nights and less sunlight. So we're gonna spin, Michelle?
Yes.
Around as the Earth, but now I feel sorry for her. Don't spin while you're leaning, so we're gonna sit you up straight, okay? So this is solstice point. Whenever your face faces the sun and revolve around one revolution and face the sun again, that is one solar day, right? Yes? And over there, right, away in the sky, if you face the star and when you spin around like that and face the star again, that's one star day. Okay? Right, now this is the orbit of the sun. So don't spin around 90 times, just a few times to demonstrate, and move around to a quarter of the orbit. So,
What, spin
yes,
around?
a few times.
Okay.
And move to this position here, facing the star again. You getting my point? Yes, everyone? Facing the star over there again. 90 days have passed. So we've got 90 star days. Good so far? Not, please. But the sun is still to our left. We still have a quarter turn to go. And a quarter day is how many hours? 6 hours. So the star's gone ahead 6 hours in 90 days, right? So far? Now we need minutes, not hours. 6 hours, how many minutes? 6 by 60, 360. 360 over 90 days, log off the 0, that's 36 over 9. The answer is? 4 minutes, QED! Now we happen to be over here, and even if Michelle leans forward a bit, imagine spinning around, and we're at Equinox, equal day and night. And if you repeat this to December, we're going to have solstice, maybe we have some special on, I don't know, okay? So that completes our little playtime and demonstration. Thank you to my past and future presenters. You've been tricked into that. So we have two pieces of homework, please. The first one, Pluto. The first one is about Pluto, which was, what was it?
Promoted.
Yes, Pluto has been promoted to what? And reply to the email, the e-Scorpius post, please. And the second one, when you get home, please think about how you personally will explain this concept to anyone who asks you why we have 4 minutes star time ahead of solar time. Okay, thank you to everyone here. By the way, I cut my teeth on an excellent book, and the concept was explained very well in here. This cost me now $15, and I want to lend this to anyone in this room for 1 month and get it back to me next time, next talk, this time. Anyone wants one? Free loan. Fantastic. Thank you. Love you all.
Sky for the month. Who's going to be presenting Sky for the month? Okay, looks like it might be me. If I can find out where it's gone.
I thought somebody was going to ask me to have a dance set or whatever goes there.
Okay. said, this was prepared by Mark a little bit earlier. He baked this one up and sent it on, so I'll quickly go through it as best I can, reading what he's got. So he's covered October and November, given that we're a good fraction of the way into October. So Mercury's at its best for evening viewing at the moment, so that will typically mean that it's getting on for furthest away from the Sun, so it's not too close to the Sun. Venus close to Spica in Virgo, Alpha Spica, and Alpha Virgo, sorry. Uranus is at opposition. Now opposition is a term that literally means it's on the opposite side of the Earth from the Sun, so that you're getting it lit up to the maximum possible. So whenever the planets are at opposition, that's usually when they're going to be biggest and brightest to, or certainly brightest to look at. Moon and Jupiter are close together twice during the month, and when two or more bodies are close together, it's something called a conjunction. And the Moon, Venus and Mercury are together in the sky as well. We'll show some of those charts afterwards. And the full moon has actually passed. And in November there's some more conjunctions there. Venus and Jupiter close together in the sky, and the moon as well on other times during the month. Mars, Mercury and the moon together, and the full moon just slightly a bit early on the 12th of November before we actually meet. Now, showing here the southern sky, we see a projection of the horizon down the bottom here, and if you look really carefully you'll see that's south, where the S is there, east is over where the E is on the left there, and over here, west horizon is over on the west there. As you see during October, we see the Southern Cross, which is down here upside down, almost down at the horizon, so it's at its lowest point. Around about midnight, so this is saying 11 p.m. at night, it says on this, which actually makes sense because at midnight the Southern Cross is highest in the sky around the 1st of April, around April Fool's Day, so 1st of November is 6 months later. So instead of being highest in the sky at midnight, it's lowest in the sky at midnight as well. You'll also notice here that we're starting to see some of the summer constellations come through, and the winter constellations are disappearing. So 11 o'clock at night here you see Scorpius is going down on that side, whereas over on this side you're starting to see Orion arising in the east, and Orion is typically a summer constellation, whereas Scorpius is a winter constellation, and because in mythology Scorpius was sent to kill Orion, so that when Scorpius is rising, Orion is setting in mythology. So that's why we see them both on the opposite sides of the sky always. Looking north in the sky, so you see north down here, we see really low down, about 10-15 degrees up, the Andromeda galaxy, which is very prominent for people that live in the northern hemisphere. Very difficult for us because of course Melbourne is in the way, but if you go north of Melbourne, where you have a dark sky looking in that direction, you should be able to make out the Andromeda galaxy. It is visible to the unaided eye, but you need a dark sky, and it is quite large. So you're not talking about something the size of the large Magellanic Cloud or the small Magellanic Cloud. It's quite bigger than that. You'll notice also the dotted yellow line there of the ecliptic. And the ecliptic is the plane of the solar system that the planets roll around, like marbles rolling around on a tabletop. And if you notice at the top there, you'll see Jupiter and Saturn. I'm sure there's a pointer there somewhere.
The white stick in the corner.
There's a white stick in the corner, okay, right.
Very high tech.
Right, the enemy is here. Right, so the ecliptic is the dotted yellow line, which is the plane of the solar system, that you're looking out through the solar system. And as you notice, indeed, Jupiter and Saturn sit right on that plane. And over here, Uranus is very, very close to that plane as well. So they don't all exactly sit on the plane, but they're very, very close to it. And same during the daytime, you're going to get the other planets move through there that we're not actually seeing here because they're not in the sky at that time of the day. So what are the planets up to? Mercury reaches its greatest elongation from the Sun on the 20th. Now that just means that it's the furthest distance away from the Sun. Normally Mercury never wanders far from the Sun because it's very, very close into the Sun. But on the 20th, it's as far angular away from it as it's going to get. So in other words, if you're going to look at Mercury, that's the safest time to look at it. The least safe time to look at it is when it starts getting very, very close to the Sun. Venus is low, setting low on the western horizon as it goes down during this month, so you're not going to be seeing much there. The days are getting longer now that the vernal equinox has passed last month, and as Sky mentioned just before in the demonstration, the equinox is the time of equal day and equal night, so equal length of those. Mars starts appearing in the morning sky, which means to actually see it, you're going to have to get up after dawn. Jupiter over in Ophiuchus, one of the zodiac constellations that never quite made it into the zodiac, number 13, getting lower in the sky. So to see actually Jupiter, we're running out of time very, very quickly for this year. So the magnificent Saturn is moving into the western sky, so that's starting to get lower as well. Reaching what's called eastern quadrature. Now quadrature is just a fancy name that means the angle between the Sun, Earth and the planet that you're looking at is 90 degrees. And as Mark actually rightly points out here, that what that means is because it's 90 degrees, at the time that the Sun sets, that means Saturn is right up at your zenith, high in the sky, so 90 degrees from where the Sun is actually in the sky. And that's the best time for actually looking at the shadows of the rings being cast onto the planet's surface. Uranus is certainly at magnitude 5.7 is visible to the naked eye if you're in a dark side and you use averted vision. And by averted vision I mean don't look directly at it, look slightly above it, because then you'll get a more sensitive part of your eye seeing it. Neptune, which is a bit too faint for looking by your eye directly without a telescope or binoculars, is also still visible in the sky in Aquarius. Appearance of the planets during October. Mercury goes from a gibbous shape early in the month to what effectively looks like a half moon shape, down to a crescent shape, and as you see the size of it changes, and that's all to do with the distance that it is actually from Earth. So the orbits of Earth going around the Sun and Mercury going around the Sun, occasionally at parts of that orbit the two are going to get closer together, and the planets will get larger as you get closer together.
What time's the best time to grab Mercury before it goes down?
After dark.
No, well I think I see Mercury and it went down about 7 or 8 o'clock.
It will go down no more than about 45 minutes or so after sunset, so you've got to get in pretty quick. Venus, as you see, is not a perfect circle, so it's still it's a gibbous shape, and that varies a lot during the year and also in size. Mars is tiny. Saturn is still pretty impressive, and Jupiter's quite large still at the moment. As you see, the relative sizes of when you get down to Uranus and Neptune, they're even smaller than Mars to see, and they're usually just like a greeny blue dot, even in a telescope. So in the evening twilight, later in the month and getting on for early November, what you're seeing here is the winter constellation of Scorpius. So you see the scorpion shape of the tail there, and the head and the claws of Scorpius. Mercury and Venus are very close together in the sky with the crescent moon, and you're only talking about 10 degrees above the western horizon. So 10 degrees is half a handspan, so very, very low in that part of the sky. Pluto, well, forget about Pluto. Yeah, you won't stand a chance unless you actually take before and after photographs separated maybe by a couple of weeks, and even then you'll need something to be able to reach down to magnitude 14 successfully to find it. But it is a good exercise if someone wants to ever give that a try, to actually try and see that. A couple of comets in the sky at the moment. I don't know enough about the details of each of those. But you do get them from time to time. Diary for the month of October. He's highlighted a couple of things here. Moon is at perigee, which means in its orbit of the Moon going around the Earth, it's not a perfect circle, it's an elliptical shape, and perigee is the closest point. So in other words, the Moon is closest to the Earth on the 26th of October, and Uranus is opposition on the 28th, so on the opposite side of the sky from the Sun. In November, what's it highlighted? Mercury is at its ascending node, and what that means is the orbits of the planets aren't exactly the same. Mercury in the ascending node means in its orbit going around the Sun, it ducks slightly up above the ecliptic and down, and the ascending node is the half where it's actually moving upwards, rather than the descending node, which is the other way around. On the 22nd, we've got the asteroid Ceres, very, very close, 0.7 of a degree south of one of those NGC objects in the sky. Now, 0.7 degrees is about a moon width, or just over the moon width. And Mercury at its greatest elongation to the west, 8 p.m. on the 28th. So in other words, on the 28th of November, your best time for seeing Mercury would be not long after, well, 20 degrees away, so you're talking about less than an hour, or around about an hour after sunset, then it will be set.
I think I saw it around about 7:30, just before Eastern the time change.
Yeah. And there's some references that he's given, and that's sky for the month. Now I'll hand over to Ian to give us a bit of trivia.
I've been sitting there thinking a bit. Hurts a bit to think.
Would you like a big stick?
Yes, I'll.
Give us some stick there.
I'll ready for this. Yes, for anybody to take me on. Yeah. Anyway, mention there of Uranus. Mentioned Uranus, and that got me thinking, what kind of planets ever come to opposition?
Superior.
Superior, that's the magic word. Superior. What's a superior planet?
Planet beyond the Earth's orbit of the Earth.
Planet that has an orbit that's what?
Greater
than the Earth, that's right. It's between, it's never, it's greater distance from the Sun, and you can have a situation of a lining up between Sun, Earth and planet. You can't do that with a planet like Jupiter, like Venus or Mercury, because they're inferior planets. So it all applies to all the planets that go around and have larger orbits than the Earth. So it does that. Now, how can you observe one of these planets, presuming you can identify it by seeing it? How can you observe it without reading any almanac or any information from anywhere yourself? How can you observe it and say it's at opposition? Can it be done?
In the zenith at midnight.
Mm-hmm.
In the zenith at midnight.
Correct. It's overhead, it'll be overhead at midnight. If it's overhead at midnight, it's at the opposition. So people don't forget that, they look it up in tables and what the hell, you can just look yourself to see, like Jupiter and Saturn, obviously they're interested.
It'll also be rising in sunset.
Yes, but then that's, yes, sunsets are sort of a variable, you don't necessarily know the moment of sunset, do you?
No.
No, but you can know the zenith, you know the zenith, so you can do that, yes. Anyway, that was one of the things. The other thing is I went to a trivia show last week, and I sat there for 3 hours and we went through, and it answered 100 questions. And only one was astronomical. It was talking about the zodiac. The zodiac comes in. The zodiac comes in. Now there's a whole body of people who are not aware that the zodiac applies to constellations in the sky. It's just the aspect of zodiac, of course, is superstition. I'm Taurus, so because of my birthday, I just look up and see what Taurus, what it is, what it says. Says that I should be wealthier this month than any other, or something like that. That kind of thing, but it affects me, and it's sort of directed at me, and it's got to give you some sort of notice that these things are written up, and there's got to be a benefit somewhere. There's got to be a benefit. You can't get people all bad news. So they mix the benefits with the bad news and make up something. But then again, the question was, what zodiac constellations, or what, no, not constellations, zodiac signs, what zodiac signs are not a living animal, living either a mythological or a real animal.
Libra.
Yes, Libra is the scales. That's the only inanimate object. Notice when they deliberately do that. Now, one astronomer had the job of naming constellations, and he named 14. That's quite a large number, and over a short period of time, around about 1850 in South Africa. Not Herschel. No. He was a Frenchman, a French monk. You don't know?
1850, you say?
Around 1850s, in the 1850s. He came to, Herschel had been there for 10 years or so. Herschel did a long time there, but this fella came and he was there for 2 or 3 years, something like that, and he named all these constellations. And he deliberately made it. What did he make with it? What was the, what do you reckon that he named the constellations? He named the constellations, and what about animals or whatever? Every one of these constellations is named after what?
Scientific instruments.
An inanimate object. No animals. Not one of the 14 that were added. When you think of telescopium, microscopium, all these constellations in the sky. Yeah. You still haven't heard of the
I wrote an article on this about 2 years ago, and I've forgotten his name already.
What's French?
It was in the newsletter about two years ago.
Yeah.
Was
Nobody
Napoleon a
would
star
say his
data?
name, right? That he.
Was Napoleon a star data?
No.
He liked his own stars.
Well, I'm trying to think of his name myself. Well, I know he definitely did do it. Anyway, well, that's what we'll all do. We'll all find out what his name was. But these all came on. They were not there in the star maps, but they came there about the 1850s. But after people made contributions and that thing. But by about 1900, then just about all the constellations were known, except that there was a grouping. There was a big constellation that was broken up. What was that one? Argo, yes. The ship Argo Navis was reckoned it was too big, so they broke it up into 3. Now, what were the 3 constellations? Carina the what? Carina the what? What part of the ship?
Keel.
The keel?
Vial, the sails.
Papas the
poop.
Poop, the stern. Stern. And the other one was, starts with a V.
Viola. Viola.
Vela. V-E-L-A, yeah, Vela the sails, right, Vela the sails, yeah, that's right. That's fair enough, yeah. Okay, I think that's enough because that time, we're going to get away tonight. You two want to get away tonight. So,
We can't leave until we get that French name.
The French, I know, I've really got it. I'm just thinking of a start to it now.
Can I ask
It's
why
not the same.
Libra
The
is the only one that is?
Wasn't the sail or the sage?
That's something like
La Place.
Probably because of that. I'd like to say.
Anyway, it's a French
Is there
name.
anyone that was it named after an animal?
Yeah, no, he deliberately named all these constellations. He picked them out and named them.
Yeah.
And gave them names that were inanimate objects, and he reckoned there were enough of them in the sky, so he deliberately, like telescopium, microscopium,
Oh,
things
but
like
how-
that.
how
Not
did-
necessarily
How did we
astronomical.
survive though? And the others took on names of animals.
Could have been
Well,
the
they'd
idea.
already been named, you know, they're already been named by, come from the, they started off in the
I look at the
And are you
encyclopedia.
asking why Libra's the only one in the zodiac 12 that
Yes.
is inanimate?
Well, that goes back, they're talking more than 1000 BC. The zodiac was originated, it goes back so far that no one's going to be able to tell the origin of any of these things. Somebody dreamed them up, and they were all happening. It was
His name? Do you want his name?
Yes.
Yes.
He was Nicholas Louis de La Salle.
1730, 1762.
That's the one, that Frenchman he's on about.
Yes.
Very good. Who is he?
Right, now we got his name, that's right. That's
On
good.
that basis, it wasn't 1850.
It was around 1850s.
17.
1750s. I'm sorry, 1850s, no, it was 1750s.
He was 100
Better give it away. It was 1750s, wasn't it? 1750s.
What was his name again?
So he wasn't there, I'm sorry, I've given you a bump steer.
No wonder we couldn't get it either.
Yes, because Herschel was there 100 years later. Yeah, that's right. Anyway, sorry.
Thank you, Ian.
I'll be better prepared next month.
Program alarms threatened to force an abort at the last second before touchdown on the moon. But the crew didn't have to abort. Instead, they were able to reboot the lunar module's computer and continue the landing mission safely. And it all came down to a man no one's ever heard of, Hal Laning. In 1957, when the Soviet Union launched history's first artificial satellite, Sputnik, J. Halcom Laning, who went by Hal, was a 10-year veteran at the MIT Instrumentation Lab, now known as Draper for its founder, Dr. Charles Stark Draper. As it did for scientists nationwide, Sputnik opened the potential for Laning to use his engineering background to explore the new ocean of space. Laning had a unique background to bring to this new challenge of the space age. He'd previously worked on the guidance system for the Polaris missile. Polaris, it's worth noting, was more than just a missile. It was launched from a submarine, which meant that its internal guidance system had to know where the missile was and where it was going, in spite of swelling seas. That meant that it had to have a fixed base as a reference point, something that was achieved via a gyroscope establishing the inertial platform on board. This is an oversimplification, but between the gyros and the onboard computer, Polaris could get to where it was going. It was actually half analog with a digital differential analyzer. It needed both analog guidance logic and digital logic, and that was Laning's element. It wasn't long before Laning began applying his background to studying a potential mission to Mars. The idea was to develop a simple satellite with a gyroscope at its core to keep the whole thing stable in flight, an optical sighting system to gather navigational data points, and a digital computer to manage everything. The idea was that the optical system could take in-situ measurements and feed the data to the computer for a running check of the spacecraft's position. In this way, it could self-maintain its navigation. This, of course, went against both NASA's and the US Air Force's idea that a human on board the spacecraft would bring necessary reliability. But it wasn't enough for the computer to run checks on the spacecraft's position. The computer's ability to check the spacecraft's position in real time meant that it could choose any alternate course of action at any point in the flight, essentially real-time thinking and reacting to changes. All of this early work on a Mars mission remained theoretical until April of 1961, when Robert Chilton from NASA visited the instrumentation lab. The space agency was starting to figure out how it was going to get to the moon. Yes, though Kennedy hadn't announced the moon landing yet, NASA was already considering it as the next step, and the team at the instrumentation lab was known for solving these kinds of problems. Chilton was impressed with the team there, including Laning, and immediately saw the potential to parlay the early work on the Mars mission into Apollo. Because even though there would be men on board, there would be so much to do to keep the spacecraft on target that it made more sense to make it as automated as possible. When some of that Mars team got to work on the guidance program for Apollo, Hal Laning reprised his role as the man behind the digital computer. He brought his Mars heritage to Apollo. The computer developed was a 3-layer computer system. At the bottom, ruling all the low-level instructions, was a computer language called BASIC, all lowercase, not to be confused with the algebraic compiler programming language called BASIC, all caps, developed in the 1970s. Every line of code in Laning's BASIC equated to one command to the computer, making it an assembly-level language, convenient for computer experts to use, but a really steep learning curve for engineers who thought in vectors and matrices rather than in registers shuffling bits around. A much larger and heavier computer could have provided a large variety of more engineering-friendly commands, but under the given constraints, the only way to provide such commands was by emulating them in software, a system called an interpreter. Fortunately, the higher math operations, like calculating a mid-course correction burn, could tolerate the slower operation of the emulated commands, so Laning's interpreter made a workable second level. Running above the 2 command levels, basic and interpreter, was the executive. The executive program determined the order in which each program ran. Taken together, the interpreter and the executive were the equivalent of the operating system for the Apollo guidance computer. And it wasn't by accident that Laning named both after human jobs. His idea was that just like people in the lab talk and follow hierarchy, so too would the programs in a computer. But there's an element in Laning's executive program that made it not only revolutionary, but vital to Apollo's success. In the early 1960s, programs in real-time computers kept it simple by running like a washer and dryer. Each program step takes its set amount of time and you run them in a fixed sequence. But Laning didn't like that approach. He knew that there would be more urgent matters on an Apollo flight, such as astronaut commands and data uplink from the ground, and also variable timing for running necessary programs. So he developed the executive to add an asynchronous element to the computer. At any given instant, the computer could work on only the highest priority programs, but events could change those priorities multiple times a second, and it was the executive job to halt one program and run another accordingly. To the human operator, it looked like the programs were running simultaneously, but the computer was actually swapping between programs every few centiseconds, so it only looked simultaneous. But it didn't matter. It was fast enough for the spacecraft and its crew. What the executive effectively did was to run programs in their priority order. This kept resources clear for critical programs at critical moments. The drawback was that it was, to some extent, unpredictable. There was some concern that a bug or an unanticipated situation could make the computer unable to proceed. The solution was an auto restart function that could reboot the computer without the executive losing track of what it was supposed to be running. So what do those 1201 and 1202 program alarms have to do with any of this? As Apollo 11 was getting close to touching down on the moon, the rendezvous radar, not even in use at that time, was in a rare abnormal state that falsely made it pour bits into the computer at the maximum rate, wasting over 13% of the computer's time. The executive found that there were no more spaces in the computer to run new steps of essential programs. This triggered the 1201 alarm signaling executive overflow, no core sets, and the 1202 alarm signaling executive overflow, no VAC areas. These in turn triggered a software reboot, which was Laning's fail-safe. All jobs were canceled regardless of priority and then started again in priority order, quickly enough that no guidance or navigation data was lost. But it didn't clear up the issue. The computer was still overloaded by the same spurious radar data, stopping new program steps from running. In all, it triggered 4 1202 alarms and 1 1201 alarm. Eventually, Buzz Aldrin noticed that the 1202 came up when they entered the verb 16 noun 68, a program that would display the range to the landing site and the LM's velocity. The command itself didn't place a heavy load on the computer, but with the existing load, that extra bit of processing power seemed to trigger the 1202 alarm. Realizing this, the solution was simple. Ask Houston for the data instead of calling it up from the computer. Houston, as we know, gave Apollo 11 a go on all 5 1201 and 1202 alarms. If those alarms had been closer together, it could have wiped out navigation data during a reboot, but being separated by even a few seconds meant that the vital information was retained. It also helped that the spacecraft computer rebooted about 10,000 times faster than a desktop PC does now. Effectively, it was Laning's foresight that allowed the LM computer to reboot itself in a matter of milliseconds while still flying. The priority scheme worked. Thanks to Draper's Hack the Moon initiative for making this video possible. To find out more about Draper's role in getting Apollo astronauts to the moon, check out wehackthemoon.com. The site chronicles the engineers and technologies behind the Apollo missions and is full of thousands of never-before-seen images, videos, and stories about the people who hacked the moon. Be sure to check out wehackthemoon.com, and for more vintage space every single day, be sure to follow me all across social media. And if this is your first time visiting Vintage Space, welcome, and consider subscribing so you never miss an episode. Thanks, and see you guys next time. One of the most dramatic moments in Apollo 11...
So wouldn't it be good if Windows could reboot itself in a matter of a couple of seconds without losing any data?
One of the interesting things about all of that is if you ask the question, why did it happen? It happened because Buzz Aldrin forgot to turn off the radar, the altimeter radar, which wasn't supposed to be used until he took off. But the thing was actually measuring the altitude and feeding that back into the operating system while they were landing.
Yeah. Manual procedure.
But it's 50-year-old.
Absolutely.
It's 50 years old. This is the computer situation 50 years ago.
And they still haven't solved it.
Hi everyone, today's video is a bit of a collaboration with Cody from Cody's Lab, and he's made a video about an interesting telescope of his own, but today I wanted to tell you the story about a telescope which I visited back in 2013, which has a very interesting history. So this is a photo that I took in Texas at the McDonald Observatory. This is a photo of the outside of the dome of the Harlan J. Smith telescope. I spent a few nights there with an astronomer who was helping to identify exosolar planets. So we were doing follow-ups to discoveries made by the Kepler spacecraft, which was out there looking for planets going around other stars. Now this is a picture from inside the dome at the telescope itself. You can see it's quite a big one. But what's really interesting is something that I saw one night when it was particularly cloudy and there wasn't really much for astronomers to do other than to kind of sit around and wait for it to clear. And what we did was we went out into the dome, and the astronomer I was with moved the telescope so that I could see right down through it into the base, into the primary mirror. And this is what I saw. So this is the primary mirror with several holes here, and these are indeed bullet holes. Now that's a very interesting thing to see on a telescope. I haven't seen that on any other telescope since. So in 1970, a very disgruntled member of staff at the observatory, after firing one shot towards his supervisor, fired 7 shots straight into the telescope, I guess in an effort to damage or destroy it. The mirror though, which was made out of 32 centimetre thick fused silica glass, didn't shatter. It just has these bullet holes which bear a mark of the incident. The mirror and the telescope also survived a few blows with a hammer in, I guess, an attempt to make a bit more damage. Now, luckily no one was hurt in this incident, and the person responsible was quickly arrested and taken away to get some mental health help. Now, the telescope in question is a Cassegrain reflecting telescope, and what that means is that it looks like this. We've got a mirror at the back. In this case, it is 2.7 meters wide, and the light comes in, reflects off this primary mirror, which is concave, up to the secondary mirror, which is convex, and then is brought to a focus down here behind the telescope, where you would put your camera or any other instrument. So the primary mirror here is actually a donut shape. It's got a big hole in the middle where the light is focused through. Now, in some preliminary reports from the sheriff about the shooting incident, he noted that the telescope was completely destroyed because there was a big hole in the mirror. So maybe it was just the case that he wasn't so familiar with the telescope design. Now, to put the record straight, the observatory came out and released a statement which cleared up how much damage had actually been done, and I'll read that to you. So, the harm suffered by the mirror from his bullets and his several preliminary blows with a hammer was extraordinarily small. The damage is limited to small craters about 3 to 5 centimetres in radius, which reduce the light collecting efficiency by about 1% and introduce a very small amount of diffraction. Astronomical observations of all types are essentially unimpaired by this tragic episode. The telescope resumed its observing program the following night, producing some of the best photographs of quasar fields so far obtained with this instrument in its first year of use. So these bullet holes, which were back here on this primary mirror, don't cause any black spots on the image in much the same way that any specks of dust on either of the mirrors or any other obstructions inside the telescope, including this mirror here or the big hole in the middle of this one, they don't show up either. Even with an obstruction, the light that is still here unblocked is enough to give us the full picture. It is true that any obstruction will reduce the total amount of light coming into the telescope and making its way to your instrument, so the image will be a little bit dimmer, but in this case these minor obstructions have caused such a low loss of light collecting efficiency that it doesn't really matter that much. And this telescope that is still there is still able to take parallel rays of light and bring them to a focus. The telescope is focused out at infinity, so anything that was so close to either of the mirrors would be so blurred and out of focus that you just wouldn't be able to see it. It would become a problem if, say, one of the mirrors was completely covered in dust, because then you'd have an issue with the dust starting to scatter a lot of the light. But as it were, the astronomers at McDonald just took the bullet holes that were left after the incident and blacked out some of the edges of the holes so that you didn't have so much light scattering, and went on to use the telescope for research-grade astronomy. For nearly 10 years after the incident, the telescope reflected a laser off of mirrors left on the moon by Apollo astronauts, and this helps to refine measurements of the distance to the moon and also provide a test of Einstein's theory of general relativity. This telescope also went on to study a lot of the planets in our solar system and helped with spacecraft who were exploring those planets. The telescope has also looked at the composition of stars, the motions of galaxies, and as I mentioned before, the search for extrasolar planets. It continues to be used on every clear night of the year and has even just celebrated its 50th birthday. Now, Cody has made his own video about a telescope. This is kind of the inverse case of mine. He's taken his telescope and put a cap over the top and made a few holes in that cap. So instead of having our view possibly obstructed by a few bullet holes, this time we only have a few holes with which to see an image. So go and check out Cody's video if you want to see a very practical demo of some of these ideas with telescope optics. And thank you for watching.
And one last one about breathing in the noble gases, and we'll call it a night.
Alright everyone, welcome back to Cody's Lab. So, in front of me here I have samples of each of the noble gases. These are the least reactive of all the elements, and they comprise the column on the far right of the periodic table. I have them arranged in increasing atomic weight. So the members of the noble gas family are of course helium, neon, argon, krypton, xenon, and radon. Now, unfortunately, radon is very radioactive, decaying in just a few days. And so its sample is represented by this chunk of uranium ore, which has radon as part of its decay series. So, well, what am I going to do with all these? Well, I have many things planned. Very low temperature coolant, balloons, neon lights, welding. I used xenon to make frog scuttle. But I think today we're going to do something fun, and that is I'm going to breathe in all of these gases to see what it does to my voice. You may already know that helium causes your voice to go all high and squeaky. All right, so as you can see, I have transferred the gases into balloons to make it a little bit easier to work with here. And we can also demonstrate a few of the properties such as density. So the helium I've got weighed down with these magnets. You can see helium does take off and float. It's much less dense than air. Neon is also less dense than air, but of course I do have this heavy clip on there, and there's not very much in this balloon, so it doesn't float, but you can see it is quite light. Argon, a little bit heavier. It feels like I just filled the balloon with air. Krypton is noticeably heavier. It feels heavy, it's got a little bit more inertia than the argon balloon. But the xenon, oh my gosh. It's like, it almost feels like it's attracted to the ground. It's just so heavy. Let's do the argon and xenon. Hi. You see, the xenon is much heavier and it falls much quicker. So a quick word on safety. I definitely wouldn't recommend breathing in random gases on your own. The noble gases are very unreactive and they all occur naturally in the air. Argon, for instance, is about 1% of the air's composition. But of course, helium and xenon are much more rare. The main concern with breathing in pure versions of these gases is they do not support respiration. They displace the oxygen and you can suffocate. There is one more concern, however, and that is, especially down here with xenon, maybe krypton, is they actually can dissolve into your blood and interact with your brain chemistry. It has an anesthetic effect, very similar to nitrous oxide, except it's possibly a little bit more powerful. Just in case, I do have Kangen hanging out nearby, and she can always call for help. So, I believe the plan is to breathe the gas, and I'll say something, and then I will do some breathing to get rid of the gas from my lungs, and then I'll go to the next gas. What should I say? I'll probably just, maybe, all right everyone, this is helium. That's probably good enough. I'll say that for each of the words. At least we'll have the all right everyone that is the same for each of them. So, here's the helium. So a good, you guys probably know what's going to happen here. Here goes.
Hi everyone, this is helium. Oh yes. My fingers are dirty.
Much fun. Okay. Neon.
Alright everyone, this is neon. So, it is higher pitched than normal air, but not nearly so much as the helium.
Okay. I started to get tunnel vision there. So definitely displaces the oxygen. Probably should give myself a little bit longer in between each sample. I'm worried for the xenon. Alright. Kangen's over there with her phone. Alright. Argon, well, that's normally in the air, most prevalent. Alright everyone, this is argon. A little bit deeper than normal air, I'd say. Just sounds like I'm just a big burly guy. Okay. Put that on my lungs, let me get some oxygen. For Krypton. I don't remember, was Superman's homeworld named after Krypton, or was Krypton named after Superman?
Superman.
We know. Tell me in the comments. So, Krypton. Let me read it. Have a dark green balloon.
Hi everyone, this is Krypton. Sound like I'm from Krypton. This is great. Oh my gosh. That was good.
You can go fit over. Okay, my hands are a little bit tingly from the Krypton, so I don't know if that's psychosomatic or what. So I might give myself a little bit longer before the xenon. Alright, it's time for the xenon. Here he goes.
Hi everyone, this is Xenon. Oh man, that stuff is heavy. Whew, it's hard to get out of your lungs. Whew. Oh, my ears are ringing.
Lips are all going numb. I didn't even get all of it in. Yeah, I'll save that. Something else. Whew. That xenon hits you hard. I think this is the most I've ever had at once. Alright. Get it all sealed up. Not sure it's all out yet. There we go. Oh, he's shaking. There you go, xenon. So, there's the one more gas. It's the radon. So let's just get some of that now. Hi everyone, this is radon. Well, a few atoms of it. Certainly not enough to change my voice in any way. If I did have enough to alter my voice, the radioactivity of it would absolutely kill me. And I wouldn't live long enough to get cancer either. Just the heat generated from its decay would absolutely be enough to just burn everything. I'd probably drown in my own fluids within minutes. And I'm sure there's some of you out there that are like, oh, but you see, element 118 was also discovered to be in the noble gas group, so unless you have a particle accelerator, you can't have all of them. Yes, that is a noble element, if it follows the periodic trends. We don't really have enough to have had any experimentally verified chemical properties. Mathematically, we've figured out, though, that it probably wouldn't be a gas at room temperature, assuming you could remove its radioactivity. It'd probably be a solid, in fact. So it wouldn't be a noble gas anyway. So, there you go. If you did gather enough of it together, like a similar number of particles to what I had here with the other gases, and you didn't suppress its radioactivity somehow, just gather it all together in one spot, and you have a little, it's probably like a sugar cube in your hand. You'd probably look at it and just see a flash of light. Its half-life is a few microseconds, I think. And the energy released would be, well, it'd be an atomic bomb. It would form a mushroom cloud and everything. So, it's probably not a good idea to do. I guess I ought to talk about why my voice went so deep when they breathed in the heavier gases. It has to do with the speed of sound. The larger particles, they don't move as fast, have a slower speed of sound, and the vibrations happen slower so, or faster, depending on the weight of the gas. And that changes the pitch of your voice. So, incidentally, it works with a whistle too. In fact, I've done xenon through a whistle, so I'll link that video. Hope you enjoyed this one. I'll see you next time.
You still alive, I show.
Here goes.
Alright everyone, this is helium. Alright everyone, this is neon.
Alright everyone, this is argon. Alright everyone, this is krypton. Alright everyone, this is xenon.
Alright everyone, this is a few atoms of radon.
Amazing. Okay, and with that, if, does anyone have anything else to bring up? Okay, well I'll close the meeting, and we'll see you all here next one.